Imagine a cosmic storm so powerful it could strip a planet of its atmosphere, leaving it barren and lifeless. This isn't science fiction. It's a real phenomenon astronomers have just witnessed for the first time on a star beyond our Sun. But here's where it gets controversial. Could these violent eruptions be the silent killers of potentially habitable worlds? Let's dive into this groundbreaking discovery and explore its jaw-dropping implications. Astronomers, using the European Space Agency's XMM-Newton Observatory and the LOFAR radio telescope, have captured undeniable evidence of a star hurling a massive burst of material into space. This eruption, known as a coronal mass ejection (CME), was so intense that any planet in its path would likely lose its atmosphere entirely. CMEs are no strangers to us. Our Sun produces them regularly, driving space weather and creating phenomena like auroras on Earth. But witnessing one on another star, that's a game changer. And this is the part most people miss. While scientists long suspected other stars could generate CMEs, concrete proof had remained frustratingly out of reach, until now. Joe Collingham of the Netherlands Institute for Radio Astronomy, Astron, and his team have finally bridged this gap with their research published in Nature. We've managed to confirm, for the first time, that material has definitively escaped into space from another star, Collingham explains. This breakthrough wasn't just about spotting a CME. It was about detecting a unique radio signal that only appears when material breaks free from a star's magnetic grip. The culprit behind this eruption is a hyperactive red dwarf star, located about 130 light-years away. Red dwarfs are smaller, cooler, and dimmer than our Sun, but don't let their size fool you. They pack a punch. This particular star rotates 20 times faster than the Sun and boasts a magnetic field 300 times stronger. It's a recipe for extreme space weather, and red dwarfs, like this one, are the most common hosts of planets in the Milky Way. Here's the kicker. If a planet orbits too close to such a star, repeated CMEs could strip away its atmosphere, reducing it to a lifeless rock, even if it's in the so-called habitable zone. This discovery raises a provocative question. Are red dwarfs, despite their abundance, less likely to host habitable worlds than we thought? The habitable zone, often likened to the Goldilocks region where conditions are just right for liquid water, might not be enough to protect planets from these stellar tantrums. Henrik Eklund, an ESA research fellow, puts it bluntly. Intense space weather around smaller stars could make it harder for planets to retain their atmospheres and remain habitable over time. The study also highlights the power of collaboration. LOFAR's new data processing techniques, developed by Cyril Tass and Philippe Zarka, were crucial for detecting the radio signal, while XMM-Newton provided the star's temperature, rotation, and X-ray brightness, details essential for interpreting the eruption. Neither telescope alone would have been enough, notes David Conan, a PhD student at Astron. We needed both. Beyond its implications for exoplanet habitability, this discovery expands our understanding of space weather across the universe. ESA's missions, from SOHO to Solar Orbiter, have long studied these phenomena, but now we're peering into the extremes of stellar behavior. Eric Qualkers, ESA's XMM-Newton project scientist, emphasizes, this isn't just about stars, it's about our search for life beyond Earth. Understanding how CMEs vary by star type is critical for that quest. So what does this mean for the future? As we continue to explore the cosmos, we'll need to rethink how we define habitable. A planet's distance from its star might not be the only factor. Its ability to withstand stellar eruptions could be just as crucial. Here's a thought to leave you with. If extreme space weather is the norm around red dwarfs, are we overestimating the number of potentially habitable worlds out there? Let us know your thoughts in the comments. This is one debate that's just getting started.